Welcome to CS264 Software Design. This is Lecture 8 and this is Lesson 5. And in this lesson I'm going to talk about reflection in C#. Now reflection is when executing code can read its own metadata information on its types, modules, assemblies, etc. at runtime. So we use the namespace system.reflection to do this, and this enables the inspection of data about the loaded assemblies, their elements such as their classes, their methods, the value types. So with reflection, your code can view an object and determine if it has some method, like say some method, and then call that method if required. It's called invocation. So reflection also allows the dynamic creation of an instance of a type and bind that type to some existing object. It's possible to determine the type of an existing object and access the properties of that object. Reflection gives us access to the attributes and provides objects of type that describe modules, assemblies, and types. So attributes in C# are declarative tags that are used to convey information to runtime about the behaviors of various elements like classes, methods, structures, enumerators, assemblies, etc. in your program. We use them in debugging, for example. And in C#, a declarative tag is depicted by the square brackets that's placed above the required code element. And we won't be doing it in this particular lesson because we want to keep it short, but you could check that if you want. So in order to understand reflection, there are a few basics that you have to understand about assemblies, modules, types, and members. Now you've seen some of these already, so let's look at the ones we haven't seen. So an assembly, and I've talked to some of you about this in person, of course, that's an automatically generated file that is created by the compiler upon every successful compilation of your .NET application. So it's a DLL or it's an exe file. We tend to work with the DLLs and we run them using the .NET run command. But you can, of course, create executable files as well under Windows here, .exes. It's generated only once for an application, and upon each subsequent compilation, the assembly gets updated. So in C# then, assemblies contain modules, modules contain types, types contain members. Okay? So you can read more about assemblies on the Microsoft.NET documentation site, and also a really nice summary from CodeGuru at this link here, which I've included in the document. So when you write a C# program that uses reflection, you can use either the type of operator, or you can use the getType method to get an object's type. You've probably seen me use these methods in some earlier lessons. You can create a type browser within your application that allows you to select types, then read the data provided about them. And you'll notice that I've used this approach to distinguish between different kinds of commands, subclasses in the previous lesson. So we'll go straight into an example here. And the program actually is not a program above, it's a program below. Okay, that uses something called the is operator. You may not have seen this already, but checks if the result of an expression is compatible with a given type. Tests the expression against a pattern. So I also use the as operator as well. So in C# you can have a whole bunch of other operators you may not have come across before to perform type checking and type conversion. So we have is, and that we use that to check if a runtime type of an expression is compatible with a given type. As, we explicitly convert an expression to a given type if its runtime type is compatible with that type. And we can have a cast expression to perform an explicit conversion as well. And we use the type of operator to obtain the system.type instance for a type. Okay? And the latter part of this program is quite long, but we'll run through it. The latter part of the program actually demonstrates what's called late binding or dynamic invocation. And that's a powerful C# reflection tool and allows us to create an instance of a given type, invoke its members at runtime without actually having any compile time knowledge of its existence. So using late binding, you are responsible for passing the correct signature of methods before encoding them or invoking them as strings, really. So you have to be careful, of course, because late binding can impact on the performance of your application. You don't do it as a norm. It's just something you do. Okay, so the program is here. It's called MyReflect. So let's jump over and see if we can get it up and run it. Okay, so yeah, it should be here. MyReflect. There it is. Okay, so we just okay, so now we have the code here. It's that the one that's included in the Markdown document. Okay, and so let's run this program. Okay, so we can see that this program is running and we look at some of the output. So it's all fine here, and let's have a look at the code. So I create this static class called reflection test class here. Okay, and in this class, It's a static class, okay? So, you know, we can have just one. We can't create instance of this, object instance of this, okay? It's a utility class. So it has an X, Y, and R and shape fields, and it has a single method called write reflection details. So what happens here is this particular method self-inspects. So it actually looks and determines the type of the reflection test class, okay? Prints that class, and we can see that it does that here, okay? And then it iterates over all the fields. So first of all, it gets the fields as an array of fields, and then it iterates over the fields, and depending then on the field type, so if the temp, which is a temporary variable that we use here to get the field name, okay, here are the fields, we iterate over all the fields, we get the name of the field, and we get the value of that field, and we can iterate over that. And if it is an int, then we can write out that it's an int, and if it's a string, we write out it's a string. That does everything. As you can see that this works just nicely here. So we're able to self-inspect when called. And we can go down to our program, and we can see here that I created this class, which is another class, and set the default values at the time. Oh, sorry, that was a different one, sorry. Where did I do this? Yeah, okay, yeah. I created a method here, and public static void main, okay. And we just, yeah, so that was okay. I just did some work with the reflection class here, set the default value to 100 for X, for Y, and R was 500, set the circle, and we made a little space, and then we wrote the details. We call this static method. So, okay, so that's how that particular one worked. Okay. So next, then I had also created something called a class called another class. Okay, so this is obviously a non-static class, and here it is the another class, and that again is similar to the static class up here, and it has some properties and it has some fields. Okay, the properties have getter and setters, and the fields are just regular fields. Okay, it also has a method called hello, which allows me to say hello from this particular method. So let's go down to the program again and have a look. Okay, so I also wanted then to be able to, in order to be able to work with this, I need to be able to get something from the current assembly. So I'm using the system.reflection.assembly type here to create this info variable, and we can get some information about the current assembly. So that tells us something about the executable program, then what's in the current assembly as well. We can just get a link to the executable program. That's getting a link to yourself. We can pull out the types, and then we can iterate over all the types and find all the classes, the methods, the parameters associated with those in the actual running program. And you can see that I've done that. Here is the assembly. That's this current program, and it tells me that there was a reflection test class, and I can see all the methods that were there, including the ones that are there and I didn't create, like toString and equals, for example. Then in the class another class, you can see all of my methods here, my getters and setters, and just I have my values and my variables here. And of course, for the program itself as well, we see all the other methods that are available. And we will determine all of this information directly once we had a link to the current assembly and the executable program. Okay. So now let's have a look at the creating an object of this class, that I had up earlier in the program. So here was the class, a class, and it was another class. It's very simple. It just creates some circle information here. And now let's see what we can do with this. So it tells me something about that class because I just get the type, and then I'm able to get all the fields and all the properties using a static method. So here I just did all this work manually, but I created a static method here, static methods inside the type. So this iterates over all the fields and the properties. So you can put this kind of information into methods that you can reuse. So I run them here, okay? And you can see that I'm able to run this information here on this particular class. I get the fields, I get the properties, okay? So now once I have those properties, I'm actually able to extract out the actual information for this. So normally I would use this aclass.x to get the property, but I can actually get a property value as well using reflection, and I've done that here, okay? And it's a nice, easy way to do this. So the final thing that I want to be able to do with this particular program is to show you how you can actually create an instance of an object in your program as part of late binding, and then invoke a method on that object. Okay, so here we have a link to the current assembly. Again, it's called MyAssembly. We're creating and getting information about the class, and we're going to create one, get information about this another class that's in this MyReflect package. Now we can use the activator method, a class, to create an instance of this particular class and call the method called getMethod, the hello, okay, we call this hello, and then invoke that method, okay, and then read the key. And you can see here we've done this, okay. And so all that happened is that we were able to do and call a class, create a class using a string, and then access a method using a string rather than calling those methods and things directly, okay. So that's it really for this particular one here. A lot going on in the program. You need to read the code, run it, read it again, and see how it works for you. So we learned about reflection in C#. Again, it's a powerful tool. It enables you to use the code that wasn't available at compile time. And reflection allows an application to ascertain information about itself and perform some kind of self-manipulation. It can be used really effectively to find all the types in an assembly and or dynamically invoke methods in an assembly. Thank you for watching.